At Interactive Engineering, we build machines that can read text and build semantic structures so that they understand the text and can make use of the knowledge in it. In 2014, we built a semantic system to read U.S. health insurer policies and answer member questions. The industry fields about 1 billion calls a year, and each insurer has thousands of policies. Interactive Engineering's technology beat out around 15 other companies, landing our licensee a multi-million-dollar contract from one of the largest U.S. health insurers. We built that system by hand, but now there's a better way. But first, what's wrong with the current systems? You can make a semantic system work while largely ignoring the multiple meanings of many words. If you stick to a narrow but valuable domain, for instance, U.S. health insurance. Even for medicine, it doesn't work very well, as you'll see in the following examples. Combine several fields, and the reliability is terrible. For example, the word set has 74 different meanings. So what's the solution? If you want to make a semantic system more general and potentially more profitable, you have to start worrying about what words mean in different areas. Words carry meaning, often many meanings. AI hasn't attempted to handle this problem, instead running on associations or statistics or keywords, which is fine when nothing changes, like the rules of chess, or when the request is simple, like turning up the volume. But it can also be potentially deadly when tasks are complex, or when things change rapidly in our world. For example, you might want to combine the following. As you can imagine, this opens up a real Pandora's box. Okay, so the system doesn't know a word, so why not let it use the dictionary? This poses a few problems. Only human-readable dictionaries are available. The dictionary staff become part of the machine's resources. And a bigger problem? People who write dictionaries have no idea what the person does when they read an entry. We have to fill that gap using an understanding of the unconscious mind. When we talk about a dictionary, we don't mean a dog-eared book that is out of date. We mean an internet interface to a continually updated database of the meanings of 800,000 words and concepts. For example, social distancing. The machine finds a word it doesn't know. It looks it up, gets a file of all the meanings of the word, builds them into an internal structure, and continues. At the same time, the machine gets regular updates on its existing vocabulary, new words and new meanings for existing words. In response, it changes its internal structure or its understanding of the world. The machine also has to do a lot of work cleaning up the entries, making them suitable for a machine level of accuracy. Here's an example of how the unconscious mind works. This road has 2 sets of lane markings. A sign tells you which one to use. The unconscious mind takes the instruction and modifies your lane following the software with a temporary hack. With the conscious, you not having a clue where it is or how it works, we need to emulate that ability, the ability to read stuff and change the system internally. So why not use an artificial neural network? An artificial neural network is static. It is directed and it runs on statistics buried somewhere in the network. It is completely at odds with an unconscious mind approach, where the structure needs to be active, undirected, and its workings identifiable. So the unconscious mind can change them. And preferably it has real-time situational analysis, so it is continually assessing the fit of the solution with the problem. We don't need AI techniques that are incredibly brittle and don't fit together. We need an artificial unconscious, which can modify any part of the system under its control. Some rules? Everything needs to be controllable through a textual interface. We will get to voice later. That means all the current AI technologies aren't going to be of any use. What about existing technologies? Chess-playing programs can beat anybody. Shouldn't we be using that technology? No, and here's why. Let's have a tournament. A human and a program turn up. We slightly change the rules and they start playing. But you can't do that, as it was programmed for a specific set of rules. It is called reality. The rules are always changing under your feet. The bottom line? We can't use brittle solutions that aren't modifiable through words. The rules of chess were last changed 250 years ago. What business can say that? It's an ingenious approach, but useless in the real world. One more thing. Can these AI methods add two numbers together? It's not the way they work. They use statistics or scenarios within a rigid framework. They can't build new structure when they encounter something new or someone tells them something they need to know, because you can't tell them anything. And we don't have to go to Mars to find a new and dangerous environment with no statistics. It's right here, right now, thanks to CC or COVID-19 or anything that is unprecedented like mega-blaze bushfires. The unconscious mind can be your worst enemy, whether standing on Mars or doling out pills in a hospital dispensary. Both can be deadly if you are bored, distracted, tired, or just lazy. You revert to unthinking behavior, and you are dead in seconds on Mars. Or that nice Miss Brown in Ward 7 dies from the wrong dose. There are 160,000 unnecessary deaths a year in the USA. The solution? Have a machine that can both read and run situational analysis. It tugs at your sleeve before you make the mistake. So what's our competition? People are. But fortunately, humans aren't very good at complex problems as they have a 4 pieces limit. The very best human mind can only handle 4 pieces of information in play. It is a serious limitation, which machines won't have. But we don't notice it because we all have it. Humans also don't like tedium. Our solution can handle intellectual drudgery better than people can, like plowing through 1 million Google hits. What about existing applications? Google hasn't changed their search methods in 20 years. It would be good to describe what you're looking for and send it off to find what you want in a morass of irrelevant hits. That means an active piece of structure, turning itself around as it compares itself with a piece of text, looking up a word it doesn't know, not the excruciating dumbness of keyword searching. So why hasn't this been done already? The bottom line is, people do what they know. They follow the latest craze. Expert systems, neural networks, intelligent agents, machine learning, deep learning. The marketing guys are experts at coming up with names that promise a lot and deliver very little. Why so little? Static structure from static thinking, or the laziness of statistics or keywords. The unconscious mind and its abilities provide a far better guide, but a far higher mountain to climb. But what about potential competitors? After all, once they see what it is, won't you have 1 million competitors breathing down your neck? No, because they have completely the wrong people for the work. Our solution requires people with English baked into their bones and the understanding to construct intricate semantic devices, the sort that a 5-year-old child is constructing unconsciously. By the time they have found and trained the right people and get it to work, at least 5 years, we will have moved up the chain of complexity. So how big is the market? Truthfully, you'd laugh if we were to put the number on it. Or in other words, how long is a piece of string? Our solution will go everywhere because the wet version is everywhere now. And it badly needs help as the society increases its velocity and complexity. The applications are limitless. So, what's the money for? We expect to be signing licensees in 12 to 18 months' time, and we will need people to support those licensees. We'll need to find people who have the capability to have some insight in their unconscious mind, which means they will be rare and expensive, and almost certainly won't come from computing. So they'll need a lot of training. They're static and directed thinking, which they were trained to do. We will get failures. Let's say we spend $5 million and we might get 3, 1 to replace the founder and 2 to support licensees. So how confident are we? We've been working on laying the foundation for 40 years. Why do we think we are anywhere close? Because we say we are. Getting the machine to clean up its own definitions will be the base for many simple but worthwhile applications. Finding the right people, on the other hand, perhaps not so easy. After all, there may not be 5 people in Australia with the right mindset. Why is this different? Because of all the things it is not. It owes nothing to all of the current or failed waves of AI. Prologue, expert systems, intelligent agents, machine learning, deep learning. The reward for those bold enough to join us on this journey? Fantastically large. So, are you up for the challenge?